Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 4, RK Bali Navigation book. This book is the 4th revised edition. Nevertheless, the questions are still the same, be it 4th edition book, 5th, 6th or the 7th edition. So let's begin with question number 11. Simple question. Parallels of latitude except the equator are what? So this is the basics of great circle, rhumb line, latitudes, longitudes. Let's say this is your Earth. On this Earth, there is this equator, which is your 0 degree latitude. 0 degree parallel of latitude. Now this 0 degree parallel of latitude or the equator is both a great circle and a rhumb line. But any other latitude except the equator, 10 degree north, 20 degree north, 30 degree north, anything other than that, these latitudes are only rhumb lines, not great circles, because these latitudes run in a constant direction of east and west. Okay, constant east-west direction, and by definition, rhumb lines are lines with a constant direction. So option A is the right answer. Question 16. A chart is given. The distance between two positions, chart distance is 20 centimeter. The scale, have to find out scale. Earth distance is not given to us directly, but we can calculate that using rhumb line distance formula. D long in minutes into cos lat. D long, difference between these two longitudes is 10 degree into 60 cos 60. Cos 60 is half, so 300 nautical miles. Earth distance is 300 nautical miles. Okay, so they have given us two positions. One is at 2 degree west, another is at 8 degree east. Both are at same latitude 60 degree north. So the distance between them is the rhumb line distance because they are situated at same latitude separated by two different longitudes. So scale will be equal to chart distance upon earth distance. 20 centimeter divided by 300 nautical miles. So 20 centimeter divided by 300 into 1.1852 meter into 100 centimeter. So we have equated the units of numerator and denominator. So 20 centimeter divided by 300 into 1852 into 100, that is 55,560. Dividing numerator and denominator by 20, you get a value of 1 divided by 277,800. So this is your scale. Okay, always bring numerator 1. So 27. Correct option is this. 2,778,000. Yeah, so option A, the closest option. Okay, next. What type of projection is generally used for charts for navigation in the North Poles, South Poles? So you use polar projections. Question 18. When an aeroplane is flying at a task of 180 knots on a track of 090 and winds so and so, how far can the aeroplane fly out from its departure and come back in 1 hour? That means endurance is 1 hour. Task is 180 knots. Let's use CX3. Task is 180 knots. True course is 090. Wind speed and wind direction 045 at 50. Outbound ground speed is 141 knots. Outbound ground speed, okay, you're going from A to B. Outbound track 0900. Homebound track coming back to departure 70. Outbound ground speed as we have found out is 141 knots. Homebound ground speed will be what? So change the values. Task remains the same. True course becomes 270. Wind velocities remain the same. So coming back, you will be flying at a speed of 212 knots. 212 knots. This is your PNR position. Here it's not given explicitly, but looking at the question, you can use PNR formula and find out the distance it can go to and come back in 1 hour. So now let's use PNR distance formula. Endurance, homebound, outbound. 141 into 212. 29,892. That divided by 353. So distance to PNR will be equal to 29,892 divided by 353, which is 84.6 nautical miles. So correct answer here is option alpha, 85, the nearest option. This following information: ground speed, heading, drift angle is given, task, temperature, what are winds? Now drift is 5 degrees starboard. 5 degrees starboard drift means heading will be less than your track. So heading in this question is 0900. So track will be more than heading. So it will be 0900 plus 5. That is 095 degrees. Substitute the values in CX3. Ground speed 520. TAS 480. True course 0905. Heading 0900. So winds will be 59 knots, 320 degree at 59 knots. Option Bravo is the closest option. Question 20. Simple runway direction is given. Winds are given. What is the headwind component? Now the formula for headwind component is minus wind speed into cos theta. Theta is equal to winds minus runway direction. Wind speed 35 knots correction. So wind velocity is 35. Runway direction is 083. So 35 minus 083 is minus 48. Substitute here. Wind speed 35 knots into cos minus 48. So cos minus 48, 0.66 something into 35 is 23.4 knots. Okay, 23 knots, and plus minus cos 48 will give you minus sign. Minus into minus is plus. That means you are getting a tailwind. If the final answer is in plus, you are getting a tailwind. So let's draw this diagram for knowledge. This is your north datum. This is the runway direction 083 in 08. This is runway 08. This is runway 26. Winds are coming from 35 at 35. So that means this is a headwind. So, okay, this is a headwind. So cos minus 48 is plus 0.66. My bad, it is plus 0.66. So plus into minus is minus. So you will be getting a headwind of minus 23 knots. Option Bravo. Okay, so looking at the diagram, you come to know that this is a headwind of 23 knots or 22. So if you take off from runway 080, you are going to experience somewhat left crosswind. Okay, a crosswind, left crosswind, and headwind. So 20 is Bravo. So we'll stop here. We'll do the next questions in my next video lecture. I hope you have understood all the 10 questions that I have done in this video lecture. Practice these questions many times without looking. Set a timer so that you also have a good time management practice. In my next video lecture, I will be solving the next remaining questions from this sample paper. Don't miss those lectures. See you there.